Okay, good morning to everyone, and welcome to our meeting in the form of a lesson now. Okay, today our lesson is still on. Okay, boy. I'm fine. So today our lesson is still on chemical reactions, but we are going to look at reactions of metals with oxygen. Okay. Um, so your presenter is still myself. Okay. Um, so we are going to look at reactions of metals with oxygen. So yesterday we were looking at what different ways of representing chemical equations. Okay. So here, what we are anticipating by the end of the lesson is that you should be able to explain or understand what happens when a metal reacts with oxygen. You should be able to identify what the product is. We saw that yesterday, so it's a continuation. We should be able to represent the general reaction between metal and oxygen. We should be able to explain combustion reaction. We should be able to look at rust and how does it form, and then we should be able to see uh, we how can iron be made more rust resistant. So here is just like trying to prevent rusting. Okay, so yesterday we were looking at chemical equations, uh, using chemical equations to represent reactions. So we said chemical reactions can be represented with models. We saw that. We said chemical reactions are usually represented with symbols, such as in the chemical equation. So we said chemical reactions can be represented using symbols, pictures, and formulae. And we said the subscript indicates the number of atoms of an element found in the formula. And we said the numbers in front of the compounds indicate the ratio in which the molecules react. So, for example, if I have two molecules of hydrogen reacting with a molecule of oxygen to form water, then therefore the ratio is going to be 2:1. And then we said at the end of the day, the number of atoms are, we don't have atoms losing or atoms gaining in a reaction. What happens is that they just simply rearrange. Okay. All right. And then we also looked at a balance equation. Now, the equations that we used yesterday, for example, iron reacting with oxygen to give us iron oxide is known as Ruston. So here, when a metal reacts with oxygen, we are going to get what is called Ruston. All right, so we'll be using that equation, so take note. All right, so that is what we did yesterday. Now, today's lesson is going to be reactions of metals with oxygen. So let's look at the general reaction of metals with oxygen. Okay, so generally, when metals react with oxygen, we get what? Metal oxide. You will have to take note of that. Okay, so some metals react with oxygen during burning. Okay, so another form or another way of saying it is what? Combustion. So anything that reacts with oxygen undergoes what? Combustion reaction. And two, when a metal reacts with oxygen, a metal oxide is formed as a product. So we should understand that metals reacting with oxygen is combustion, and the product formed is what? Metal oxide. So the general equation for this type of reaction is always written like this. It's a word equation. So we have the metal plus oxygen giving us what? Metal oxide. Now let's look at reaction of what? Iron with oxygen. So when the metal ion is burnt in air, which contains oxygen, the reaction forms is what? Iron oxide as a product. So let's look at the word equation. A word equation is I plus iron plus oxygen giving us what? Iron oxide. And then the chemical equation is what we have here. But this equation is not balanced. So we have seen, let's look from the at the previous slide. This is the previous slide. So you see, when iron reacts with oxygen, we are getting what? Iron oxide. And then when we balance it, so we remember we said when we are balancing the chemical equation, the atoms or molecules on the left hand side should be equal to those on the what? Right hand side. So if I check my ion on the left, Fe is 4, then it should be balanced with that one on the right. So which is 2 times 2 to give us 4, and then 2 times 3 will give me 6. So how will it be balanced here? I put 3 in front, which is the what? The coefficient. So 3 times 2 will give me 6. So this is an example. A metal, iron is a metal reacting with oxygen to give us what? Iron oxide, which is the same thing as what? A metal oxide. So metal oxide is just a general statement, but the specific metal that reacts with the oxygen will give you that metal oxide. So iron oxide will give me what? If iron reacts with oxygen, will give me what? Iron oxide. If sodium reacts with oxygen, I will get what? Sodium oxide. If calcium reacts with oxygen, I will get what? Calcium oxide. And remember, that process is also known as what? Combustion reaction. Okay. All right. So the previous one is balanced. This one we are looking at here is not balanced. So here the question can just say just write the general equation or a word equation or chemical equation. But if the question, if you can balance it, it's fine. But if the question is saying it's not talking about you balancing, but just to represent the formula, it can also happen sometimes. Now we have looked at how iron react with what? Oxygen. So let's look at what? Magnesium reacting with oxygen. When the metal magnesium is burnt in air, which contains oxygen, the reaction forms what? Magnesium oxide as a product. So as I said, so a word equation is going to be magnesium plus oxygen giving us what? Magnesium oxide. And the chemical equation is going to be Mg plus O2 giving us MgO. So remember, it's not balanced, but we can balance it also. So how do we balance it? Can you try to balance it for me? Just check. I will check through the chat room. Try to balance it. Mg plus oxygen giving us MgO. Guys, try to balance it, and then I see. Guys, are you balancing it? Hello, guys. Are you there? Okay. Yeah, that's good. Yeah, perfect. Perfect. You omitted 2 in your oxygen, so just check. That's okay, but you are correct. Okay. Yeah, that's great. Okay. Meaning you are listening. Thanks very much. Okay, let's get moving. So as those of you who sent in, you are correct. So oxygen. So first of all, we start with oxygen. We can see that we have got 2 atoms of what? Oxygen here. We have got what? 1 atom. So to balance it, we cannot put any subscript in between. We are only qualified to put in front. So if oxygen is 2 here and is 1 here, to make it balanced, we put 2 in front of magnesium. And remember, when we put the 2 in front of magnesium, it affects the whole compound, which is magnesium oxide. So if oxygen is 2, it has doubled from 1 to 2, then it has also increased magnesium. So what happens is that we write 2 here. So the way some of you balance it, you are perfectly correct. Now let's go to the next. Okay. Now, so let's see how we can write the general formulas further. A metal oxide has the general formula MO. Okay, so we can have uh, compounds that will react with oxygen and we'll just get MO. We can get metals reacting with what? Uh, Oxygen, and we are getting what? M2O. Okay, so in the formula, M represents a metal atom and O represents the oxygen atom. We can therefore say that metals from group 2 will react with oxygen and have the following general equation, where M represents what? A group 2 metal. Okay, all right. So the one that we saw, magnesium reacting with oxygen is what? We know that oxygen is in group 6, magnesium is in what? Group 2. Okay, all right. So if you check. Now, to know whether MO or M2O will be the correct formula, here are two simple rules for you to remember. This is a suggested way to assist learners to write the formula. Once learners have learned about valences in group 12, it will even add more. So for now, we are just giving you the basic as to how to write the formula. But as you go, what we are doing here, you repeat it in grade 10 up until grade 12 and even further. Yeah, but in grade 12, in the FET, oxidation numbers will also be added or will be introduced, coupled with what you are also learning here. All right, so metal oxides from group 1 on the periodic table will have the what? Formula M2O. Okay, look at the periodic table. If you have it around, pick any two metals from group 1 and write their formula using this rule. Any two of the following should be right. So group 1, they have a what? They are in group 1 and they will lose one electron in their outermost shell. Okay, so oxygen will gain 2. So when they are going to form, they will cross. They will, meaning they will exchange their what? Charges. So the two, let's look at lithium oxide. So lithium is in group 1, but how is 2? So meaning for lithium oxide to be formed, we need 2 atoms of lithium to give us what? L2O. Okay, so all group 1 metals will react to give us what? M2O. So this is why we are getting lithium 2O. We are getting sodium 2O. We are getting potassium 2O. And we are getting cesium CS2O. All right. Now, what about group 2? What is the general formula for metals from group 2? Okay. All right. In group 2, we have got, if you look at your periodic table, we have got magnesium, we have got beryllium, we have got calcium. All right. So if a group 2 metal react, the formula will be MO. Can you write some examples? Yes. If you were to write, you will find out that some of them will be like this. BeO. So look at the difference between metals group 2 and group 1. In group 1, the general formula is M2O. In group 2 is MO. Why? Group 2 metals, they have got what? They will lose 2 electrons so that they will carry a charge of +2. And remember, oxygen is in group what? 6. It will gain electrons and be what? -2. So when they react, they cancel out. So that's why we have BeO. Okay. Mhm. Yeah, on computer, yes. Sometimes, yeah, the subscript is always smaller. Yeah, you are right. It's smaller in terms of font size. You are correct. So, for example, if you look at Na2O, the Na2 should be 2, but it should be smaller, smallish, and it should be below. Yes. Yeah, that's a very good observation. Yeah. Okay. Now let's go on. So write the word equation for the reaction between iron and oxygen. For the reaction between what? Magnesium and oxygen. Can you write that for me in the chat room? Write the word equation for the reaction between an ion and oxygen, and then for the reaction between magnesium and oxygen. Yeah, post post them now so that I will see, then we can move ahead. It's just a word equation. You remember, one way to represent the chemical equation is by word. Okay. Yeah. All right. Yeah, not, it must not be balanced. Yeah, for a word equation, you are just writing the word. Yeah, but when you write chemical equation, even if they say it's not balanced, you can try to balance it. Or sometimes they just want you to say, to see how you are playing around with the chemical formulas. So if I give you a question and then say, write a chemical equation. So, and I'm remaining mum about what the balancing does it. Very good, very good. Okay, I can see that iron plus oxygen will give you iron oxide, and then that's correct. What about magnesium? The first one is iron and oxygen. Yes, that's correct. What about magnesium and oxygen? Another word equation. Yeah, perfect. That's perfect. The way your answers are coming in, and they are perfectly correct. Tando, you are welcome. On Cabbage, you are welcome. All right. The rest of you, you are welcome. But these ones, they are just joining. It's like they are late. Okay. That's great. Let's continue with the lesson. All right. So I'm very happy we understanding. Okay. Now, so we have seen how we have got a lot of metals, né? But we have just picked the basic ones and those ones that are in the ATPA for us to study about. So we have learned how group 1 metals and group 2 metals reacted with oxygen. We can also go to group 3, but for now, if you get the understanding, we can go to group 3 also. All right. But for now, let's just stay with group 1 and group 2 and other metals. You know, iron is not in group 2, but it's in group A, but it's a very, very important aspect. Okay. All right. Now let's go to formation of rust. Uh, guys, I want to ask a question. What is rust? What is rust? Okay, don't explain it, but have you seen rust before, and how does it look like if you are at home and sometimes you're looking around, you can see uh, some metals that are changing color because they have been exposed. So when they change color, it means that there is a chemical reaction that has taken place. So let's see what we talk about. What I'm talking about, we are looking at formation of rust, and we're saying rusting is a slow chemical reaction of iron metal with oxygen and moisture. So rusting is simply the reaction between a metal known as what, iron, with oxygen, and then what, water or moisture, to form a complex compound, uh, of which is what, iron oxide. So the previous slide that we saw, Fe plus oxygen giving us iron oxide, that is rusting. You remember when I was giving you what we did yesterday, that is rusting. Okay, so it means for rusting to occur, there should be what? Moisture, and the metal should react with oxygen. So for you to avoid rusting, you can eliminate one or two of the factors, and then you can prevent rusting. Okay, so let's go to bullet 3. Steel, which consists mostly of iron, is an essential material in modern construction, in equipment and structures. So equipment and structures can rust and weaken. So what it means is that if iron is exposed to oxygen and moisture, a bit of moisture, what happens is that the the metal will corrode, or it will undergo corrosion. And when it's undergoing corrosion, in simple terms, it's rusting. And as it rusts, the material becomes weaker, or it weakens. So it's no longer going to be what strong like when it was new, because part of the metal peels off. And when it peels off, the mass decreases. And as the mass decreases, the strength also what decreases. Okay. Um, Now let's look at ways to prevent rust. Ways to prevent rust. Now iron and steel can be painted to keep away moisture and oxygen. So you remember I told you that we have a metal, we have oxygen, we have water. Now, so if the metal is there and we want the metal to not to rust, then we have to eliminate one of the variables or one of the factors. It can be either oxygen, it can be water. You have to do something to prevent the interaction between oxygen or water with the metal, and then you will be fine. So one way of preventing is to paint. So we can paint. So that's why you see some metals in various places being painted. Okay. So when you paint, you are keeping away the moisture and oxygen from interacting with what? The iron and steel. Okay, iron and steel can be also coated with a what? A thin layer of chromium or zinc. So these metals do not rust. Okay, and how this is done by an electroplating technique, which is a form of what? Electrolysis. So what is electroplating? Electroplating is simply using, um, you are taking a metal that does not rust to cover another metal that can easily rust. So when we do that, it's called what? Electroplating. And as you get to FET, you will understand the chemistry behind it. But for now, to prevent rusting, we can what? Electroplate by using chromium or what? Zinc. All right. Okay, so let's go on. We're still on rusting. So when iron is exposed to oxygen in air, a similar reaction occurs, but much more slowly. This iron is gradually eaten away as it reacts slowly with oxygen. Under wet conditions, iron will rust more quickly. Okay, so what it means is that the higher the water content, then the faster the what? The rusting. Okay. So if you have a bit of it, then it what? If the moisture is a bit, then the reaction will be slow. Okay. So rust is actually a mixture of different oxides of iron. But iron 2 O3 of our earlier example is an important part of that. So this one is the example that I gave you, iron reacting with oxygen to give you what? Iron oxide. So rusting of iron is actually a good example of what the process of what corrosion. I've already spoken about that. Now, rusting tends to happen much faster near the ocean. Why? Can somebody answer this question? Or those of you who are by who stay close to where we have the ocean. I hope you are trying to answer it in your head. Okay, no problem. Let's continue. So rusting tends to happen much faster near the ocean. Not only are there water droplets, but these droplets have what? Salt in them. And this makes them even more corrosive. So what it means is that if we at the ocean, if you have got your house or your buildings next to the ocean or by the sea, you know the moisture content is high there. But in the ocean, we have got what? Sugar content in the water. And when the sugar content, the salt content rather, in the water, and when the salt content reacts with water and with the metal, the rate of rusting increases. Okay, Rusting also happens more quickly in the presence of what? Acids. Yes. Inside laboratories or factories where acids are used or stored, the air is also very what? Corrosive. So let's take note. When the air in a specific area contains moisture mixed with acid or salt, we refer to the area as what? Having a corrosive climate. Okay, so what is a climate? A corrosive climate is a place in which, mostly if you have got factories around that produces substances, so if the substances in the atmosphere are very reactive substances, they can what? React with water, and the when they settle on a substance, what happens is that the substance can easily corrode faster. So we can say the area around that factory is having a what? Corrosive class climate. Okay, if you live in a corrosive climate, for example, near the ocean, it is often better to make the window frames and doors of your house from wood instead of iron and steel because wood does not rust. Many people also use what? Aluminium, as this metal does not rust too. Okay, so if you in future, if you are by the ocean, it's better you use what? Wood for your doors and frames because wood doesn't rust, or you can also use aluminium. Okay, now let's look at galvanization. Okay, so we have got a zinc reacting with some substances uh, to make them strong. So galvanized panels used for walls or roofs. Okay. We also have what? Galvanized watering can. We have what? Galvanized floor, and we have what? Galvanized nut and bolt. So sometimes when zinc or other substances are added, they reinforce them. If you are doing technology, you would have done composite materials. Okay, so for example, this bolt and nut will be very, very strong. So galvanization is one way of strengthening and also preventing rusting. Okay, all right, now let's continue. Uh, all right, let's go to our activity for the day. All right, so again, um, we are going to look at these sentences to consolidate. Question one is saying a chemical reaction where a compound and oxygen react during burning to form a new product is called, yeah, so here you just fill in the missing word. You take note. Number two, you write the whole word sentence. Magnesium plus something is missing to give us what? Magnesium oxide. Question three, something is missing that reacts with oxygen to give us what? Iron oxide. Then we go to question four, copper plus oxygen react with uh, 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 copper react with oxygen to give us something as a product. Okay, yes. So we look at question five. Another word for iron or oxide is called, yes, let's go on. So you just send in your answer. Metal that is covered by a thin layer of zinc and zinc oxide is called, yeah, we just looked at that. The gradual destruction of material, usually metal, by chemical reaction with the environment is called, yeah, something is missing there. Okay, when the air in a specific area contains moisture mixed with acid or salt, we refer to the area as having a what climate? Something is missing there. Okay, the product of the reaction between a metal and oxygen is called, yes, list three materials that can be used to protect iron or steel from corrosion. So let's get on going with our answers. Yeah, okay. Yeah, Tando, you are welcome. You can ask your question. Yuliswa, you are also welcome. I think you are late. So you can, where is Tandy? You said you have a question. Yeah, ask. post it for me. Okay, yes. Why doesn't aluminum rust? Because it's also a metal. That is true. I'm just going to give you a layman explanation, but we have got the detailed chemistry behind that. Okay, so what is happening is that uh, group one, group one metals, group two metals, they react very fast. Okay, all right. So let's put that aside. The way aluminium doesn't is in terms of reactivity is very slow or non-existent at all. So that's why when it reacts with oxygen, you get what aluminium oxide, but that is not rusty. Yes, but if you still want the detailed chemistry about that, uh, I can I can give you maybe next time, but not here, but not today. I mean, all right. Yeah, number one is there. Onka, number one is there. Look at the top. It's the question. The activity starts or the assessment starts with question one. You is something you read it and something is missing. You have to add it. Tando, are you convinced about my answer, Tando? Yes, I'm here. Aluminium, Tando. Are you convinced, or I should explain again to you? Okay, guys, keep your answers coming. All right, but I can I said when aluminium reacts, you will get what? Aluminium oxide. Yes, and that oxide assists uh, the metal because it covers it on the surface. And then this acts as a, what? A protective layer that what will not make the aluminium to what? Rust. Yeah, aluminium. Okay, I think I need to explain this. So you guys listen. Aluminium react with what? Oxygen, and you will get what? Aluminium oxide. And the aluminium, that aluminium oxide, the compound or the product that is formed acts as a protective layer that cover the surface of the metal, and hence it will not rust. But not that it doesn't contain, because it doesn't contain zinc, iron, or whatever, it does not rust. The fact is that aluminum will react with oxygen and form aluminum oxide. And that aluminum oxide now acts as a what? Protective cover, preventing aluminium from getting rusted or rust. Okay. Okay. Yes, Onka, the question one is saying you are supposed to provide a missing word there. They say a chemical reaction where a compound and oxygen react during burning to form a new product is called what reaction? Yeah, I think it's very simple. It's just a word, and we have been talking about it so far. Yeah, just think again, you will get it. All right. So keep your answers coming. Number eight. Number eight is what I explained. You remember the last second but last. What is happening is that corrosive. I'm even giving you the answer. In number one is confusing. Chantel, you are welcome. Why? What is making it confused? There is a word. There is something missing there for the sentence to be completed. So you just need to check it out. It says a chemical reaction where a compound and oxygen react during burning to form a new product is called a what reaction? Number eight needs an answer. Onka, number eight needs an answer. There is something missing there, maybe because I didn't add the dash. When the air in a specific area contains moisture mixed with acid or salt, we refer to the area as having what? Dash 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 what climate? Or the dash dash can even come between A and the climate. So there is an answer there. Number nine. Okay, that's correct. And then the number 10 says list three materials that can be used to protect iron or steel from corrosion. Okay. Yeah, that's paint. Onka, that's paint. One. They are saying three. So keep them coming. Tando, paint. If you say zinc and chromium, that's two things. Either of them can. So you give another one. Chantel said, I think number one is oxide. Yes, you want me to give you the answer, Chantel. Okay, yeah, you write, then I will give you when you get the answers, you do your correction. But you tricking me into giving you the answer, right? Okay? Paint, zinc, and galvanizing. Zinc and galvanizing. Okay. All right. That's good. I like your efforts. You are doing well, very well in sending your answers. Okay. Are we ready to check our answers, whether they are right or wrong? Okay. Are we ready? You'll see, well, you are quiet today. All right. If we are ready, okay, let's go and get our answers. Okay. You see our answers. Number one is combustion. We have oxygen, we have iron, we have copper oxide, we have rust, we have galvanized, we have corrosion, and number eight is a corrosive climate. You remember? Yes. So those of you who said number eight doesn't have an answer, it is having an answer. And number nine is metal oxide. And then number 10 is paint, chromium, and zinc. All right, that was right. You can also, besides these ones, you can also do what? You can also lubricate them with oil. You smear them with oil. So apart from painting, chromium and zinc, then we can also oil them. We can also what? Electroplate them. Okay. All right. So this we have got various ways. Yeah. All right. Okay. So let's look at. All right. Is there any question? Otherwise, we just look at the lesson summary, and then we are done. Okay. You got them all on Kabechi. Seriously. I got them right except one. Okay, that's very good. I told you to think first. Okay. You'll see where you got all of them. So guys, try to screenshot the questions and the answers so that as your record you can be revising. Okay. If there is no question today or any question further, our lesson is coming to an end, and it was nice having you around. Very good. Someone I got 10 wrong. I got 10 wrong. Wow, why Kai? You were not listening or what? Okay. All right, guys. Enjoy the rest of your day, and then see you tomorrow. Okay, and well done to everyone. Stay blessed and stay safe. Coronavirus is real. Let's keep social distancing, sanitizing, and always wear a what? A face mask to prevent others from getting it, or to prevent us from getting it. Have a nice day and bye.